antiderivative. Kwa maneno mengine tunaita integration. Hii ndo ambayo imezoeleka sana. Sasa nini maana ya integration? Mara nyingi twende directly. This is symbol of integration. Sasa hii integration maana yake ni kwamba sum to infinity. Yaani una vitu infinity. Sasa unataka uvisum hivyo. Kuna hii normal symbol. Hii ni sum of finite things. Vitu ambavyo vina mwisho. Kwa hiyo integration maana yake ni sum of infinity things. You have things to the infinity hivyo. Vile vile tunaweza tukasema integration is a reverse process of derivation. Nadhani wote we are very familiar with derivation. Kwa hiyo hii integration is just a reverse process of it. Kwa hiyo kwa mfano tuseme kwamba tuna function. Tunasema kwamba ukisema f of x is an antiderivative of f of x means what? Hii inamaanisha ukipata f prime of x maana yake iwe f of x. Yaani tumesoma derivation. Kwa hiyo katika derivation tunafanya reverse process, tunarudi tena katika ile function origin. Unatoka kwenye ile derivative ulioipata unarudi to the origin function. That is what we call antiderivative au derivation. Kwa hiyo symbol yake kubwa kama tulivyoionyesha ndo hii hapa. Hii ambayo maana yake ni sum to the infinity. It's just the same as the normal sum, lakini hii tuna add numbers to the infinity. That is integration. Kwa mfano, twende direct kwa mfano. Kwa mfano una function yako f of x equal to cos of x. Kwa hiyo find an antiderivative au integration of hii function yako f of x. Maana yake nini sasa? Maana yake ni kwamba uki-integrate a function. Uki-integrate a function urudi to the origin function ambayo ulifanya derivation before. Kwa hiyo unatafuta ile how was the function before doing derivation. How was the function? Kwa hiyo ndo maana ya integration. Kwa hiyo tunajua katika nini tukisema kwa mfano tuashume x yetu ilikuwa nini? Ilikuwa sin of x. Sasa sin of x tulikuwa tukitafuta dy dx au kama hii ilivyo dfx dx ya hii function. Tunajua dx ya sin x. Hii tunajua moja kwa moja ni cos of x. Sasa hizi tunatafuta namna ya kutoka kwenye hii cos of x kurudi kwenye sin of x. So that reverse process of derivation, hii ndo tunaita integration. Kwa hiyo unavyozungumzia integration, that is all about integration. Kwa hiyo sasa tutajaribu kuona aina tofauti za hii integration. Kwa mfano katika integration inaweza ikawa integration ambayo sum to the infinity without any limits. Kwa hiyo kusipokuwa na limits zozote au tunasema unbounded integral. Yaani haina limit yoyote. Hii tunaita indefinite. Tunaita indefinite integral. Indefinite integral. Yaani yenyewe haina any boundaries. You add numbers to the infinity without looking for any boundaries. Alafu kuna nyingine sasa una add numbers to the infinity but within the certain limits. Hii tunaita bounded integral au unaweza ukasema definite integral. Definite integral. Kwa hiyo katika hii tena tutaiangalia definition nyingine katika hii. Kwa hiyo tukisolve hizi integral zetu tunaweza tukapata aina mbili za majibu. Tunaweza tukapata the general solution. General solution inapatikana kutoka kwenye nini? General solution pale ukicalculate hii indefinite integral unapata general solution. Kwa hiyo general solution is a collection of all integrals, kwamba ziko almost infinity integrals with a certain constant. Kwa hiyo mwisho wa siku unapata jibu lako kwenye hii kutokana na general solution inakuja in form of fx plus c plus constant, ambapo hii constant inaweza ikawa any number. Kwa hiyo normally ukiintegrate in definite integral ndio unakuja unapata nini? Unakuja unapata general solution. Kwa hiyo then tunakuja tena aina nyingine ya solution tunaita particular solution. Particular solution sasa, now you can guess it kwamba saizi tumejua value ya c. What is our c now tumejua. Kwa hiyo inakuwa fx plus c, but now c is known. C inaweza ikawa any number, can take any value from 1, 2, 3, any number can be C. So now we get a particular solution. Tunapata integral at a certain point directly. Kwa hiyo hizi ni some of simple definition. Kwa hiyo kuwa makini, unaweza ukaulizwa what is definite integral. Kwa hiyo let's see, tunaweza tukaona possible, tunaweza tukapata possible questions hapa. Possible questions. Siku hizi wanajaribu kuuliza pia haya maswali. Unaweza ukaulizwa what is definite integral, what is definite integral na indefinite. Kwa hiyo unaweza ukayajibu kwa namna hiyo. Katika definite ni kwamba it is bonded integral, na indefinite it's unbounded, yani you find the solution. Na vile vile tukirudi kwenye summary yetu tunavyozungumzia kuhusiana na this integral, just integral, let's mind it's sum to infinity. Sum to infinity. Kwa hakuna cha zaidi, yani you just try to add numbers ambazo hujui idadi yake, inakuwa hivyo. Kwa in normal cases we are adding mfano from A to B. This is when we use like normal sums, lakini for now tutakuwa maybe tuna find the integral sum of infinity numbers bounded from A to B. Kwa hiyo it's just the same case. This is sum to infinity, this is a normal sum. Kwa hiyo it sounds like that one. Kwa hiyo hivyo. Saizi sasa tuje tuone some properties of integration. Properties of integration. So ya kwanza, let's see the basic properties of integration. Ya kwanza kabisa nasema, for example, when you find the integral from A to B of fx dx, this means what? This one leads to the certain function, let's say capital F of x, from bounded enter your limits from A to B. That is the meaning. So let's also see another property, integral, the second property of integral. The second one, it's like the sum property. It's a summation property. Kwa hiyo this is like the definition of integral in general. It will explain. It's like based on the definition of integral. Now let's look for some of other properties. Kwa hiyo kuna some, as we talked in differentiation, we are seeing some different properties. So here also we can talk about this. So this also AB of fx dx, I can expand it. It can be like f of b minus f of a. This is also possible. Also, if you have integral from a to b of k of x dx, this constant k, you can get it out, can be the function dx. So the function constant can get out as usual, as we normally do. And the other property, the very common property, integral, taziona some of the properties, but the other property integrals ni kwamba you can be given, for example, AB f of x dx. So when you try to change the limits, like here I put b, here a, I make the reverse, you put negative f of x dx, it carries the same meaning. Let's change my pen to this time. Also, the other property integrals ni kwamba, for example, some property, if you have AB you have a function f plus or minus function g, let's say both of x dx. This one, when you expand it, it's just f of a b of this f of x dx plus or minus a b of gx dx. It carries the same meaning too. And the other property, the other property which is also very important, it's like when you integrate the constant one, or integrating from the same limits of fx dx, this one we may guess it will be f of a minus the f of a, so this is 0. So actually any, even if you're given from b of x dx, scales the meaning of 0. So these are some properties of integral. Now let's go and look some rules of integration. So integration is nothing more about but playing with rules and laws. So here, rule number 1, we call it power rule. Power rule. What's the power rule? Power rule says, for example, you're given an integral of x to power n, a function x to power n dx. What is this? They say this is x power n plus 1 over n plus 1. So you add 1 to the exponent and you divide by that exponent plus 1 again. But since it's indefinite integral, we add what? We add c. But if it was a definite integral, maybe ab xn dx, there was just be xn plus 1 to the exponent n plus 1, then you put your limits a, b. There was no need to add what? To add c constant. We add c when it's indefinite. This means indefinite integral. Like we don't know the limits. We need to correct all the values. That is where we get this one. So the other one, that is the power rule. And the power rule is the most common in this one. It's almost common rule. But let's see again. Apart from power rule in integration, there is no much rules, but we can see some common. We can say common integration. Common integration means some simple integration which are normally being used in integration. For example, the first one is like the power rule. We said it. Let's keep it writing several times so that we can remember it very well, because we will be using it in most of cases to solve some questions. So I can say that one is like, because we already talked it above. The other one is this: when you see the function x dx, this one will give ln of x. Since it's indefinite, like it has no boundaries, so we add c, ln of x. This is constant, it doesn't change, it's always like that. It's always like that. So the other one, it's like, maybe let's go to cos of x for this trigonometry. We can see them later on, but let's see them. So when we integrate cos, we get what? We get sine. Let's remember back. For the back, like when we differentiated the sine of x, we were getting what? We were getting cos of x. So this is what we were doing derivative. If you derivate the sine of x, you get cos of x. But now we do the reverse process. If you integrate this cos of x, we get what? This is called integrate. So in general, we can summarize like this. Here you have integration. That's why we say these processes are the reverse process. Integration, and here we have what? We have derivation. So what's the process? If you derivate, maybe you have a function here, x. If this process, if you derivate this function of x, you get a certain function. Let's say like you make a derivation, you get a function f of x. You get this one. If you derivate this one, this undergoes this process, you get a function of f(x). But if you integrate this function, you make integration of this function, it returns back to this function, which is the one which you derivated before. So you go again to this function. So that is why we call these two processes, they are reverse to each other. They are reversed. So what we do here is just returning back to where we came from. So let's go with some common integration number 3. This common integration number 3